part 2 of the dynamic process simulator building using the Visual Basic. In this part, we will talk about the planning. So let's go back again and see what we want to achieve. We want to have a typical blocks for each one of our process. A typical block meaning a block that I can use it over and over in every scenario I need. And then in the next step, we'll see how we can connect those blocks together. But now we have to know that we have to build a block which we need to connect it later on and to run it. So that's part of the planning to see what the end product will look like. So we plan accordingly. So in this video, we'll look at the process and then we define it and we plan the simulator. In the next one, we'll look at the development environment and how we build the simulator in the developing environment. But in beginning, we need to define our process. We have to define what are we going to simulate. In this case, we will look at pumps, valves, tanks, reactors, heat exchangers. Those are the type of things we're going to simulate. But let's start with an easy one. The easy one I think would be maybe a tank. So we will build a simulator for a tank. But what type of tanks? Is it circular, round, it's horizontal, it is vertical, has this odd shape, or is it maybe just a standard one? I don't know what I mean by standard, but we can agree that one of the easiest shapes we can work with is a cylinder, a vertical one. So let's take the cylindrical vertical tank as our first simulator. That's the one we're going to build. Maybe we'll have many inputs. Maybe we have one or more outputs, but definitely we have in a tank an overflow pipe. And we have all the outlet valve and pumps connected to an outlet pipe, and this pipe has an elevation, and also the overflow have an elevation. So that's H1 and H2. We may have more than one input, so we have more than one flow rate. Maybe we have more than outputs, we have more than output flow rate. At the end, we need to know the level in the tank. So our target from this simulator is to know the level at any moment. So the level always will be between the outlet pipe and the overflow pipe. It cannot exceed the overflow pipe and it cannot be below the outlet pipe. So in the simulator, we'll have a block, let's say a program or a subroutine, whatever you call it. But at the end of the day, you will have some input variables, which is a data. You put it into this block, and then there is an output, which is in our case will be the level. So the input here, they are not the physical inputs. It's a data going into our block. Into the block, inside it, you can divide it into many groups. But this is an idea of how I was tackle the problem with, let's say, pump or pipeline, that I'm thinking of what would be my initial conditions, meaning when the simulator will start. Is the pipeline will be filled? Is it will be half filled? Is it will be empty? What will be the level in my tank? Is it will be zero? Whatever I decide, but this is my initial condition. What is my properties and data of this tank or the pipe or the pump or the valve? what is curves or equations I need to use. Then what is my assumptions? I have to do some assumptions. The assumptions, let's say that for a tank, your level will never be below zero and it will never go beyond the overflow pipe, meaning your overflow pipe is big enough to take all your inputs with no output at all. All the flow rates in the tank will go through this pipe and it will never exceed the level of the overflow. And then we'll think about all the limits and constraints which is you can implement on your design. And then the internal clock. The internal clock is how often you want this block to be executed to calculate. Is it half a second? Is it 1 second? 10 seconds? Depend on your machine and process equipment, that will change. Some of the DCS or simulator will give you a defined time that everything should run into. Let's say they will give you 1 second, 2 seconds, 4, 10 seconds. So you have to make your system, all of them work within this limit. In our case here, because it's a very small simulator, we'll have every and each one of our blocks will work independently, have its own timer internal clock. Again, our output is not a physical output, it is the output of your calculation. It could be one value, could be two values. Now, if we take the tank as one example, my input data will be the inlet flow, the outlet flow. Do you want the simulator to run or not? So if it is not running, nothing happens. And how the speed of simulator, what the meaning speed of simulator? If you said that this tank calculation is made every 1 second, but you want to run the whole simulator at speed of 2, that's mean you will run it at each half a second, not 1 second. If you multiply the speed by 10, you divided your timer by 10, that means you have to do the execution every 100 milliseconds. That's to speed up your simulator and see the results of 10 minutes in 1 minute. Of course, you don't need to have all of these, but that's in general idea. Now, at the end of the day, after all things you do inside the block, what I need is the liquid level. Now, remember when we talk about what I want from this block. If you have a pump and this pump is, let's say, variable speed pump, you will have your data input is the speed command, let's say the resistance of the line or the process profile. Your input would be maybe the inlet pressure to the pump. And then what is your output? Do you want to know the flow and the pressure of the pump? So you have to define what I want to do. Now, if you have a pump in series with another pump, what about the second pump? You have to think about it. What I will get from this simulator. Maybe it's completely different than the first pump. The first pump, it's inlet coming from a tank. The second pump in series would have the flow rate coming from the first pump. So you have to think about it to see what is your output. Now let's look at the initial condition. I said, okay, when I start my simulator, my tank will be empty, so the level equals 0. I could make it level equals something. Now, what is properties and the data? The properties of your equipment, in our case here, is a tank diameter, the elevation of the outlet pump, the elevation of the overflow pump, and in the curves and equations, we have only one thing. The difference in the level equal the difference, the delta in volume divided by cross-section in a certain time. Now, if you look at the assumption, one of the assumption I said, okay, in our case, no temperature effect. It's a perfect cylinder. So there is no change in the diameter with the elevation. The overflow pipe is properly sized. And the flow rate is constant during the clock time. The limits and constraints here is your level, the elevation of the inlet, sorry, the outlet and the overflow, and the end result is your level. So to be able to calculate the level at any time, the time is n plus 1 will be equal the level at time n, which is a previous period, plus the change in the volume divided by the diameter. Change in volume is the inlet flow minus the outlet flow, and it's multiplied by the clock intervals. Now this is meter cube per hour, intervals is second, you have to divide it by 3600, the diameter in meters square, the flow rate meter cube. At the end, this would be the whole thing in meter. So the change in level in the period, let's say in 1 second or half a second or whatever time you define. So now this is the only equation we're going to use. Now what is the properties? Think about the properties as in a different way. There is some stuff which will never change ever, which is hard coded in your simulator. So one of them, let's say if I have only one block, calculate the volume of a horizontal and a vertical, then in my case I have only one, which is the vertical. If it is horizontal and vertical, then probably it's another property of the tank. The input during simulator build. So when you build your simulator, maybe you have some properties you want just to put it for the first time. You don't think you're going to change it at all. The diameter, the height, those you will go not to change it during the simulator. Then you think about some properties you have to change it during the runtime. When you do a simulator, you do it for a reason. You do it for testing something. So you think, okay, what about if my pipeline elevation increased by 2 meters? That means simply the operator, when he run the simulator, he need an access to change this elevation. Think about the parameters here in a table, put them in a table, and then each parameter, give it a name and give it a type. Think about the engineering unit. So your equation would be always okay, and look at your limit and constraint as well. So in nutshell, this is how I made my parameters. The reason I put the T underscore, when you look at individual basic later on, you will see that this make our life easier because it group them all in one spot so I can easily see them. I believe that's all we have. Then let's see you guys in video number 3, and it would be for building an actual and testing a tank simulator.